In a previous video, I showed you how to create the interpretation HSV. In the interpretation HSV, we explicitly encode the phase, amplitude, and fault information. The phase information controls the hue or colour of the volume. So as we move through the spectrum here, this is indicating a change in phase angle. The amplitude controls the brightness. So much as with many other attributes, the brighter the colours, the higher the amplitude. The fault information controls the value, or blackness. The advantages of this are for manual picking, that we can pick on a particular phase angle. Also, that visually we can differentiate many packages within the dataset, and also recognise geometries that might otherwise be difficult to see in the Seismic itself. For automatic tracking algorithms, the advantages are that the phase information reduces the risk of cycle skipping, and also that the fault information being explicitly encoded means that those faults will be honoured by the algorithm. To begin picking within GeoTeric, we simply go to the Adaptive Horizons directory within the project tree. We select the Pick Points button, and we begin by placing a seed point on the appropriate phase angle. From here, we can begin to get an understanding of the way in which the Adaptive Horizons algorithm works. Firstly, we can see that the algorithm has tracked out along this main terrace. This is because the algorithm works by following trends that are consistent with the seed picks I've placed. Secondly, we can see that this terrace has stopped against this major fault. This is because we have the fault information encoded in the volume, and thus the black lineament stops the horizon from pushing through the fault. Instead, the algorithm has followed the fault until it has reached a fault tip, and then moved around the fault plane and started down onto this lower terrace. In this way, we know that we have an accurate throw on our fault. If this fault had extended completely to the edge of the volume, the algorithm would not have crossed that line, and we would simply come down to the lower section and place a pick here. As we move over to the left, we can see that we have another fault running through the dataset. In this case, however, the algorithm has not been able to find a way up to the upper terrace. Instead, we can simply come in, find the appropriate level, and again, place a pick. The algorithm will then continue growing. From this point, we can begin to see how the algorithm has moved throughout the dataset. We can continue adding seed points until we are happy that we have a good network throughout the dataset. And once we are happy with that, we can gradually increase the acceptance level to ensure a pick of a wider range of points. We also have other methods of controlling the algorithm. We can choose to wind back the history, which will show us how the algorithm has tracked out. This can be useful if the algorithm has made a mistake. We could use this, for instance, if there was a problem here, to step in and place another seed point, thus causing the algorithm to grow more accurately from that point onwards. We also have the ability to paint and delete sections of the data. So if we were unhappy with the picking over the top of this volcano, we could simply paint and delete sections there. And if we wish to only grow in a certain section of the dataset, we can simply pick a polygon and then allow the growth to continue only within that area. Using the interpretation HSV and the Adaptive Horizons tool, we get a rapid and accurate pick based on fault, phase and amplitude information that can be controlled by the user and can allow us to control the way and the amount of detail that is used in the resultant horizon. When we're finished, we simply select the Create Horizon button, and that will then be put into the Horizons directory in our project.